At 28 weeks gestation, the human fetus appears anatomically complete. The fingers are formed, the eyelids can open, and the heart successfully pumps roughly 30 quarts of blood a day. But if exposed to the atmosphere right now, it would fail to survive without massive medical intervention. The major organs are structurally present, but the fetus lacks the autonomic operating systems required to run them independently of the placenta. To survive, the organism must shift from basic somatic growth into an aggressive phase of functional maturation. This process involves 3 specific protocols that must be executed before birth. First is neuroautonomic regulation, where the fetal brain takes control of its own core survival functions. Second is pulmonary maturation, where lung chemistry alters to allow for gas exchange. And third is spatial biomechanics, the physical repositioning required to navigate the birth canal. From week 28 onward, gestation operates as a strict biomechanical countdown. The body engineers the exact conditions necessary to successfully execute a single event, the first independent breath. This chart tracks gestation weeks against neural network arborization volume. Starting at week 28, we observe an exponential spike in neurogenesis. Millions of neural synapses begin firing simultaneously, forming permanent connections across the 2 hemispheres of the brain. The fetus is transferring the management of its life support systems away from the maternal biology and directly into its own neural network. The first major autonomous task managed by this new network is thermoregulation. The newly formed neural pathways direct the body to regulate its own core temperature, a process that must function the moment the insulation of the amniotic fluid is removed. Immediately after, the nervous system initiates a second autonomic task, rhythmic practice breathing. The brain fires signals to the diaphragm, causing it to contract. This mechanism draws amniotic fluid in and out of the lungs, forcing the muscles to build the strength they will need to pull in oxygen later. Because these internal muscle contractions are highly organized, they register against the uterine wall. Mothers experience these specific contractions as strong, distinct fetal movements. By week 32, the neurological hardware for survival is installed, but the mechanical engine it relies on, the respiratory system, is not yet viable. The thoracic cavity and the lungs constitute the final major organ system to reach functional maturity. Early-stage lungs face a mechanical hurdle. The fluid inside the microscopic air sacs, called alveoli, carries a surface tension high enough to force them shut after an exhale. This alveolus cross-section shows inward force vectors pulling the walls into a collapsed state. Between weeks 33 and 36, type 2 pneumocytes secrete a lipid protein called pulmonary surfactant. This coats the inner surface, neutralizing surface tension and preventing collapse when pushing out atmospheric air. Deploying this chemical defense requires exact timing. Peak surfactant concentration is only achieved as gestation nears week 36. As the fetal lungs expand to their full volume, they create significant spatial constraints within the maternal body. The growing uterus is forced upward, compressing the mother's diaphragm and displacing her adjacent organs. This spatial constraint restricts total lung capacity, directly causing the shortness of breath common in the final months of pregnancy. The respiratory system is now chemically viable for gas exchange. To deploy successfully at birth, it requires a precise mechanical repositioning. At week 37, a spatial threshold is crossed. Fetal mass overtakes the volume of amniotic fluid, eliminating mobility inside the uterus. This fluid-to-mass inversion physically forces the fetus into its final biomechanical configuration for birth. Evolutionary standards for human delivery require a specific alignment, known clinically as the cephalic presentation, or the engagement position. The fetus rotates into a head-down orientation. This diagram overlays geometric calculations required to align the fetal cranium with the maternal pelvic inlet. A vector path forces the widest part of the skull to navigate narrow clearance margins through the bony constraints of the pelvis. As the cranium descends into this pelvic cavity, it places weight on the mother's lower structures, driving increases in lower body pressure and frequent urination. Spatially locked into the pelvis, the fetus is mechanically primed. Any subsequent bodily movements transform from general signs of growth into vital clinical diagnostics. Late-stage fetal movement provides a measurable clinical metric known as kinematics. Tracking these daily kinematics serves as a proxy for the internal health of the environment. If an intrauterine crisis occurs, such as the degradation of the placenta or compression of the umbilical cord, a specific physiological chain reaction begins. This biological flowchart maps the feedback loop. Placental oxygen degradation triggers the fetal autonomic nervous system's energy conservation protocol. The brain executes biological triage, ceasing non-essential somatic movements to reroute the limited oxygen supply exclusively to the heart and brain. A sudden, sustained drop in daily movement is the primary warning sign of this internal triage. Detecting these hidden failures requires strict clinical protocols. Medical teams monitor movement charts and maternal blood pressure to identify distress and intervene before viability is lost. The cessation of movement is not a resting state. The fetal brain is actively executing an emergency protocol to survive a failing environment. At exactly 40 weeks gestation, the womb reaches its final resting state. The biological checklist is complete. The autonomic nervous system is online, surfactant is deployed, and the cephalic geometry is locked. The environment runs a final stress test before labor begins, executing rhythmic Braxton-Hicks contractions. These muscular wavefronts serve a dual function. They tone the maternal uterine musculature, and they test the fetal cardiovascular tolerance to pressure. The mature fetal autonomic system manages the temporary drops in blood flow caused by these contractions without sending the heart rate into distress. Biological development has reached its conclusion. The organism simply idles, waiting for the hormonal cascade that triggers labor. The third trimester completes the engineering required for the transition from a fluid-dependent organism to an independent, air-breathing human.